Hi, I'm Alex, and this is the solar system. 4.5 billion years ago, the sun was made when gas and dust collapsed. Later, moon and planets formed by matter collapsing farther out, as from task 3. This formed the solar system. The solar system consists of planets, moons, comets, and asteroids. They all orbit the sun because the sun has the greatest mass and the strongest gravitational pull, which holds all the planets together. The ratio we used to scale the size of the planet was 2,000 kilometers from the real planet was equal to 1 centimeter on our model. The scale we used to measure the distance from the sun was 1 astronomical unit from the planet was equal to 50 centimeters in our model. To make my planet, I had to figure out the distance from the sun and the mass. Everything orbits the sun. This is because of gravity. Gravity depends on two things, distance and mass. This means the more mass a planet has, the more gravity it contains, which leads to a stronger magnetic field and a stronger gravitational pull, as we learned from the gravity and orbit simulation. We also figured out the less mass a planet has, the smaller the orbit. The size of the planet also affects the sun's gravitational pull. This is why the smaller planets are closer and the bigger ones are farther away. This will affect our telescope because of the bigger planets' gravitational pull. If we get too close, we might get pulled in and ruin our telescope. This is my telescope route. First, we launch our telescope past Earth's gravitational pull into Mars. We won't have to worry too much about Mars' gravitational pull because of its small mass. Since we know the smaller the mass, the smaller the gravitational pull, we can figure it won't be a big problem. And then we orbit Mars to gain a little speed. Then we leave Mars' gravitational pull and go into Jupiter's. I know this is risky because of Jupiter's solar winds, but has anyone ever got a telescope all the way to Neptune before? If we want to complete our task, we're going to have to take chances. We orbit around the very edge of Jupiter's gravitational pull for a little and then leave it. We go straight by Uranus and Saturn and arrive at Neptune. Our group's plan to protect our telescope so we don't get pulled into a planet's magnetic field is to put an electromagnet in the telescope. This will also help protect us from solar winds. Our electromagnet, made by a coil of wires wrapped around an iron nail and then connected to the battery, this will cause our telescope to have a stronger field. As we know from task 4, when we wrapped a coil of wires around an iron nail and then connected to the battery, the more coils we had around the nail, the more paper clips we could pick up. In task 4, I investigated what attracts and repels. I also figured out what made a stronger field. This is my route past Neptune and my projection I'd use. So this is my first model. In this model, this is the solar system, and I explained my route I'd use and the magnetic field I'd use to protect my telescope. And then the closer the planets are to the sun, the faster they orbit the sun. And also these are the smaller planets closer, and as you go farther out, it usually gets bigger. The second model I used is I explained what would happen if our telescope went around Saturn's magnetic field. I talked about how our telescope would be in a constant spinning motion because the south side of our telescope would be attracted to the north side of Saturn, and this will cause our telescope to go in a misdirection and spinning around. So when we release from Saturn's gravitational pull, we don't know what direction we're going to be going in. Thank you.